Hey, geometry students, in this lesson, we're going to be talking about triangle midsegment theorem. This lesson is going to introduce the theorem, like the definition of a midsegment, what the theorems are surrounding a midsegment, and then we're going to work some practice problems in the next video. All right, so what is a midsegment? The midsegment of a triangle is the segment that joins the midpoints of two sides of the triangle. For every single triangle, there are three midsegments, and we usually look at them one at a time. Okay, so we'll be looking at just a single midsegment in just a second. But notice that I can join these two midpoints, M and P. I could join P and N, and I could join M and N. So there are three different midsegments that can be joined. And not only that, when you join those three midsegments, they also make a triangle in the middle of the triangle that has some special properties. The triangle midsegment theorem states that the segment joining the midpoints of the two sides of a triangle is parallel to and half the length of the third side. So look at NM, Q is the midpoint, and PR is the midpoint. If I join QR, remember Q is on side NM and R is on side NP, it's going to be parallel to the third side and half the length of the third side. And that's what we have down here in our triangle midsegment theorem, the actual theorem written out at the bottom. Also, I just want to point out, here is a triangle that has just one midsegment drawn. And you can easily conclude, like this midsegment here is half the length of the bottom triangle. But wait, there's more. First of all, we're going to look at this theorem and see if this sounds familiar. If a line is parallel to one side of a triangle and it contains the midpoint of another side, then it passes through the midpoint of the third side. So again, we're talking about the mid segment. Okay, you should read the mid segment in this definition. If you have a line parallel to one side of the triangle that passes through one midpoint, it's automatically going to pass through the other midpoint. So if I have these markings that show that this segment is parallel to this segment, and the markings that show that these two segments are congruent, meaning this is the midpoint, V also has to be the midpoint of ST. You can probably picture how that's going to show itself in some practice problems later on. And then we need to talk about the midsegment triangle. So right now we're just developing some terms and definitions and some theorems, and we're going to use these all in some practice problems. One of those terms we need is the midsegment triangle. The midsegment triangle is the triangle formed by all three midsegments, as we saw up above here. I'm actually going to put a new one down here with some different lettering. So again, here's a midsegment. And then if I draw all of the midsegments, I get a triangle in the middle of my triangle, my bigger triangle. Now here's the thing, that midsegment triangle is similar to the original triangle. So triangle FDE is similar to triangle BCA. Not only that, first of all, just let me prove that, because that's really easy to prove. By angle-angle similarity. Looking up here at this triangle, notice that this little tiny triangle up here has an angle and another angle that matches the angle and the other angle below, because these are like transversals across two parallel lines. So that means that these would be corresponding angles. These would be corresponding angles. So therefore, the little triangle made at the top above my midsegment, this isn't the midsegment triangle, but it is a little triangle that's made, that's going to be similar by angle-angle similarity to the big triangle that contains the midsegment. And I'm going to have all of these relationships in here. We're going to see that all of these triangles in here are similar, and then they're also similar to the big triangle around the outside. So I could state these similarity statements. Triangle ABC, the big one, is similar to EDF, that's the midsegment triangle, is similar to ADF, the little one on the left, DBE, the little one on the top, and FEC, the little one on the bottom right. All right, those are the relationships we need for this lesson. Next, we're going to work some practice problems for this lesson to be able to actually put this to use to find unknown lengths and angles inside triangles.